We want to be able to manipulate functions, that is, we want to be able to move them about the screen. Now this isn't of any use for us right at the moment, but whenever we move on to looking at frequency, phase and amplitude of our cosine, sine and tangent functions, this will become very useful. So we're going to start off here with a function f of x is equal to x squared. So you can type this in yourself if you want, and just put in x squared. Now we're going to want to manipulate this function around the screen. So for example, we may want to move the function up and down. And we can move the functions in different directions by using these different forms here. So the blue one is the original function and the pink one is the function that's been manipulated. So in this case here, we're going to generate this function f of x plus a. So this is just exactly the same as saying x squared plus a. Okay, but we're going to just write it in the general form here, f of x plus a. So whenever we add this value a, you can see here I've got a slider, and if we slide this to the right, you can see that we're able to move the function up and down. So the blue function is the original function, and the pink function is that function which has been allowed to shift up and down. And that's quite straightforward. For example, if we had a as a value of 1, then we would be generating the function f of x squared plus 1. So for example, if we went to this point here, it would be x squared, so it would be 1 times 1, which is 1. But then we would add 1 onto it, so it would then go to point 2. And the same for all the other points. So now we know how to shift the function up and down. We simply add a value to it. In this instance here, we're adding the value a, which in this instance ranges between -5 and +5. So that's quite straightforward. Now let's say we want to be able to shift the function left and right. Now we're going to use this other form here. So this form here is f of and x plus a, so the a is inside the bracket. So that's equivalent to us writing, for example, x plus a. And you can see here that the squared term, all of this term here is squared. So we'll take it out, as we said, because we just want to keep it in this general form here. So if we have f of x plus a, you'll see here that whenever we make a negative, it shifts the function to the right. And when we make a positive, it shifts the function to the left. So now we can shift the function left and right and up and down. So it means if we were to do both of those at once, then we could move this function anywhere on the screen. So let's put that back to 0 and we'll look at the next one. Now what we want to be able to do is reflect the function in the x-axis. So for example, if we reflected this, then all of the positive values would all become negative. So we do that by making the function negative. So we have minus f of x. Now the other option that we would want to be able to do is not reflect in the x-axis, but reflect in the y-axis. So for example, if we reflected this function in the y-axis, then everything at this side would reflect over to this side, and everything from this side would reflect over to this side. So we wouldn't actually see anything happening in this function. So we can reflect these by using this form here, f of minus x. And you can see here, this is the reflection. Now if we were to try this with a different function, you'd actually see it a bit better. So for example, if we were to put the function x cubed, then you can see the original function looks like this. So when we reflect it in the y-axis, this end reflects over to here and this end reflects over to here. So if we put that in, you can see that reflection happening. So again, that's just the same as saying f of minus x. So that's just like taking the x here, making it negative. Okay, and that's that reflection. Now, there's two other things that we're interested in, and that is stretching the function. So we could stretch the entire surface in the y direction, and we could stretch the entire surface in the x direction. But it's better seen by using a different function for this. So we're going to use the function sine x. Now we want to be able to stretch the function in the y-axis, and we do that by multiplying the function by a value of a. So let's put a initially at a value of 1, and you can see here that we're going to have 1 times the function. Well, 1 times sine x is just sine x, so we just end up with the same function. But if we were to adjust the value of a, you can see that the function is actually getting larger. So that is in effect stretching the entire axis in the y direction. And we call this stretching the amplitude. So this is the amplitude of the function changing. And we'll see that whenever we look at the videos on waves. And of course, whenever we make this a value less than 1, you can see that we have now made the function smaller and smaller. And when it goes to 0, we're going to have the function disappearing. And whenever it goes negative, we're going to reflect in the x-axis, and we're also going to make the function larger. Now, we also want to be able to stretch the function not in the y direction, but in the x direction. And we do this with the final function form here, which is f of a times x. And we can see that whenever the value a is 1, we're just going to have 1 times x. So for example, that would be equivalent to putting a 1 here. Okay, so it's 1 times x. But if we were to change the value of a, you can see here that we're now squeezing the function together, or we can stretch the function out, and you can see the function being stretched out here. Now, this will be seen as increasing the frequency of the function, but we haven't talked about that yet, and as I said, we'll talk about that later on in the course. What matters here is that you can see how the functions can be manipulated. So this in effect is equivalent to putting a number in here. So in the case it's 2.9, so it's going to be 2.9 times x. So we've seen how to manipulate the function in every possible way that we are interested in, simply by using this value of a in order to change the shape and position of the function.